Now, for the sequences of real numbers, we use the Binomial Theorem. 1 plus n alpha is less than or equal 1 plus alpha power n. The binomial formula is 1 plus alpha power n equals Cn0 1 power n alpha 0 plus Cn1 1n minus 1 alpha 1 plus Cn2 1 n minus 2 alpha 2 plus etc. Cn0 is 1, alpha 0 1, 1 power n equal 1 plus Cn1 equal n, 1 power n equal 1, alpha power 1 equal alpha. So 1 plus n alpha is less than 1 plus alpha power n. Some theorems about limits of a sequence. If limit of xn equal x and xn is less than L for every n belongs to n, so the limit is less than or equal L. Also, we use the theorem if we have two sequences xn and yn convergent, limit xn equal x, limit yn equal y, and xn less than or equal yn for every n, so the limit of xn is less than or equal limit of yn, x less than or equal y. Also, the theorem, if limit xn equal L and limit yn equal L, the same limit, and we have a third sequence, Zn, so that Zn between xn and yn, then limit of Zn is also L. The sequence xn tends to L, and yn, the limit is L, then also the limit of Zn is equal to L. The binomial theorem is 1 plus n alpha less than or equal 1 plus alpha power n. So 1 plus n an, if alpha equal an, less than or equal 1 plus an to the power n. So 1 plus n an less than or equal 1 plus an is radical n alpha to the power n, which is equal alpha. Radical n to the power n is alpha. So we can calculate now an in terms of n. 1 plus na less than or equal alpha gives that nan less than or equal alpha minus 1 and an is less than or equal alpha minus 1 over n. We can divide both sides by the positive integer n. Now, alpha minus 1 over n tends to 0 as n tends to plus infinity. So, an tends to tends to 0, but an is radical n alpha minus 1 tends to 0, and finally radical n alpha tends to 1. Radical n alpha tends to 1.